All right, welcome back. We're going to go ahead and do some more examples. So this first one is we are looking at an elastic collision. Okay, so remember that elastic collisions is where our kinetic energy is conserved. Okay, so before and after our collision, we have the same total kinetic energy. Okay. So we have that we want to calculate the velocities of two objects following an elastic collision, okay? And we are given the initial mass, the mass of each object, and then the initial velocity of each object, okay? So you notice that our second mass doesn't have an initial velocity, okay? So just keep that in mind. Okay, so we have one object that has some velocity going towards our other object. Okay, and that second object has no velocity. Okay, so let's go ahead and write some equations that we know, and then we can solve for velocities. Okay, so we have our conservation of momentum. Okay, and that tells us that the momentum, the total momentum before and after the collision will remain the same. So our P1 plus P2 is going to be equal to P1 prime plus P2 prime. Okay. Now you notice that our velocity in our second object here is 0, which makes P2, our initial P2, 0. Okay. So we can write this out explicitly. So remember that momentum equals mass times velocity. So this equation turns into m1v1 equals m1v1 prime plus m2v2 prime. Okay. Now looking at or understanding or remembering that an elastic collision, we know that the kinetic energy is conserved. And remember that kinetic energy equals 1/2 mv squared. Okay, so based on that, we can go ahead and write a similar equation. So K1 plus K2 equals K1 prime plus K2 prime. Okay. And again, since the equation for kinetic energy is 1/2 mv squared, our velocity, our initial velocity of the second object is 0. So this term also goes to 0. Okay, so we're left with 1/2 m1v1 squared equals 1/2 m1v1 prime squared plus 1/2 m2v2 prime squared prime. Okay, so with these two equations, we want to be able to determine a couple of values here, right? So we want to know v1 and v1 prime, and we want to know v2 prime. So again, these are the velocities after collision. Okay, so how do we do that? Well, we're going to have to rearrange these equations and plug one into another and then solve. Okay, so we're going to have to use a bit of algebra in order to do this. Okay, so I'm going to take this first equation, okay, and I'm going to rearrange it. So 1 is going to become m1 v1 minus m1 v1 prime equals m2 v2 prime. Okay. Then I'm going to take that and solve for v2 prime. Okay. So what I'll do is I will factor out my m1 and then divide everything by m2. So I have m1 over m2 times v1 minus v1 prime. Okay, so now I have my velocity after the collision of my second object, okay? But I still have this unknown here, this v1 prime, okay? So what I'll do is I'll then have this equation and I will plug it into this second equation. So I'm gonna plug this one prime into 2, okay? A couple things we can notice off the bat is that the second equation here has 1/2 in front of each term. And so I can cross out those 1/2 and it'll just be like a 1, okay? Or I can divide by 1/2 throughout and just leave with 1 in front of all of these terms, okay? So with that, let me go ahead and plug my 1 prime into 2, okay? So I'm going to get m1 v1 squared equals m1 v1, whoops, let me rewrite that. m1 v1 prime squared plus m2, and this is where I'm going to plug in my v2 prime squared. Okay, so this is going to be m1 over m2 v1 minus v1 prime, and again this is squared. Okay. Okay, so now we have this equation here. So you may notice that now we only have one unknown here, and that's the v1 prime. Okay, so what we want to do now is solve for v1 prime if we can. Okay, so what I'm going to do is I'm going to go ahead and extend this way. Okay, and I'm just going to focus on this side of the equation. I need to square out this guy here, this term. Okay, so let me go ahead and do that. So leaving the left side alone, okay, we have m1 v1 squared, and we have m1 v1 prime squared, okay, and then we end up with m1 squared over m2, because one of these gets canceled here. And then I'm going to square this term out. I'm going to get v1 squared plus v1 prime squared minus 2v1 v1 prime. Okay. Now, let me see here. Okay. What I will do now is divide throughout by m1, okay, to maybe make it a little simpler. So I get v1 squared equals v1 prime squared plus m1 over m2 v1 squared plus m1 over m2 v1 prime squared minus 2 m1 over m2 v1 prime. Okay, and at this point I know that it's looking a little bit crazy, but bear with me. I have things that I can plug in, remember? Okay, so let me see here. I am going to rearrange this once again. Okay, I know this is getting a little bit much, but it'll hopefully be looking better soon. Okay, so I'm gonna move this guy over, and then I'm gonna get all of my V1 primes together. Okay, so we're gonna end up with V1 prime. Okay, and that's gonna be multiplied by, let's see, let's do it this way. So this is gonna be V1 prime plus M1 over M2 V1 prime minus 2M1 over M2 V1, okay? And then plus V2, I'm sorry, V1 squared. We have this term, M1 over M2. And then if I'm pulling this guy over, it's gonna have a minus sign, minus 1. Okay, so hopefully you guys could follow that. If not, pause it and kind of look at what I did. Okay, I tried to make it a little simple, but sometimes it doesn't work. Okay, so there's a few things I can do at this moment. I can start plugging in my velocities or my velocity and my masses. Okay, so let me go back and remind us of our masses. So M1 is what? M2, and then what is our V1? So our M1 is 0.5 kilograms. Our M2 is 3.5 kilograms. Whoops. And our velocity is 4 meters per second. Okay. So to make this a little simpler, let's go ahead and plug these numbers in. Actually, you know what I'll do is I will go ahead and put this back in. So it might make it a little simpler, not sure yet. So V1 squared plus, we're gonna have an M1 over an M2. So M1 is 0.5 over 3.5, that's M2, V1 prime squared, minus 2 times that again, 0.5 over 3.5, oops, times V1 prime. Oh, we know our V1. There we go. Our V1 is 4.0 meters per second, right? And then that's going to be times V1 prime plus 4.0 meters per second squared times 0.5 kilograms over 3.5 kilograms minus 1. Okay. All right, so this is getting a little bit crazy. Okay, we've got 0.5 over 3.5. That's going to be about 0.143. V1 prime squared. And then this times 2 times 4 is going to be 1.4. I'm sorry, 1.14 V1 prime plus this number minus 1 times 4 squared. that is actually a minus 13.7. Okay. Now, we can combine these two values, right? So it'd be about 1.143. Whoa. 1.143 v1 prime squared minus 1.14 v1 prime minus 13.7. Okay, now as you can see, this is a familiar form. Okay, we can now solve for v1 prime using the quadratic formula. Remember that that is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so I can say v1 prime equals negative b, which is going to be negative 1.14 plus or minus negative 1.14 squared minus 4 times a, 1.143 times c, negative 13.7. All of that is in a square root and divided by 2 times 1.143. Okay. Okay, so we have 2 times 1.14 squared plus 4 times . So I get 7.92. So this will yield two answers, one that's the positive or the plus sign here and one with the negative. So let me go ahead and do that. So 1.14 plus 7.92 over 2.29. And I get a positive 3.96. Oops. Or if I have a minus sign there, a minus 2.96. Okay, so we have either velocity in the positive direction or in the negative direction. Okay. So let me make a couple of notes here. Okay, so first of all, I did not include any units, so that was bad on me. But we know that this should be in meters per second. Okay. Another thing is, if we round these off to their closest whole number, okay, we have plus or positive 4 meters per second and negative 3 meters per second. Okay. Now, in the using the quadratic formula, we may get two answers that may or may not make sense or work. Okay. And in this case, for our initial velocity, remember that our initial velocity for the first mass was 4 meters per second. Okay. Now, logically, if we think about this, we're looking at a collision, right? And they do hit each other, right? This first mass hits this second mass. And our initial velocity would definitely decrease, right? Or at least maybe be bounced off or something to that effect. Okay, something will happen to this initial velocity. It's not going to remain constant unless it completely misses the object, right? But we're saying that it does collide. It is an elastic collision, okay? So this can't be the case, okay? And therefore, this is not a solution, okay? We will just have that v1 prime is -3 meters per second, okay? So that is our velocity, our final velocity after the collision, okay? 3 meters per second, minus 3 meters per second in that situation. So it bounces right back, okay? All right, so now let's go ahead and use this knowledge to now solve for the second mass's velocity. Okay, so let's scroll. Hopefully it'll load. Well, that's interesting. Okay. Okay. So we solved for this 1 prime, right? Okay. So let's now use this to solve for our v2 prime. Okay, so looking at 1 prime, v2 prime equals m1, which was given to us as 0.5 kilograms, divided by our m2, which is 3.5. And we're going to multiply that by our v1, which is 4 meters per second. Okay, minus v1 prime, which we just solved for as -3.0 meters per second. Okay, so now we can plug that into a calculator. And we get 1.0 meters per second.